Factoring with GCF 2x minus 8. So you have 2x and 8, of course, and you can do 1 and 2. 1 can go into 2 times, and then 1 can go into 8 times. But that's not the greatest common factor between the two. And you can do 2, which can go into 2 one time, and then 2 can go into 8 4 times. But then you cannot do any number higher than 2 because it won't go into 2. So you have 2 on the outside, parentheses, and you have x there, which is next to an 8, so you leave it on the inside of the parentheses, x minus 4, which would be the answer to your factoring. And if you were to check it, which I always do, you would use the distributive property, and you would get 2x minus 8 as above. So, check. Difference of two perfect squares, a squared minus 9. So what I do when I have the difference of two perfect squares, I go through the perfect squares until I find one that gives me the number in the expression. So 1 and 1, which would equal 1, so that doesn't work. 2 and 2, which equals 4, again doesn't work. 3 and 3, which equals 9, which does work, of course. So you have a squared, so you do a, and since you have a negative here, you would need a positive 3 and a negative 3. So a minus 3 in parentheses, and then a plus 3 in parentheses. And of course, this would be your answer for the two perfect squares, but you should always check your work, and here you would use FOIL, or you can use the box method, but I prefer FOIL. So there you do that, and that, and a times a is a squared. Then you have a and positive 3, so that's 3a. Then you go down here, and that's negative 3a. And then you have negative 3 and positive 3, which would give you negative 9. Now this here would cancel out since it's a positive and a negative, which would just give you 0. So then you end up with a squared minus 9. Easy case expressions, n squared minus 11n plus 10. The first thing we're going to do, well, what I would do would be label my a, b, and c. So a is going to equal 1, because n squared is 1 squared basically, or 1n squared basically. Then b equals negative 11, and c equals positive 10. I like using the diamond method, so I'm going to go ahead and draw my diamond, and c goes up here, b goes down there. So 10 and negative 11, and I need to find factors of 10 that when multiplied, of course, would give me 10, but when added would give me negative 11. So we have 1 and 10, and then 2 and 5. 1 and 10, of course, 10 and 10, but when added, 1 and 10 equals 11, and 2 and 5 equals 7. So we can't use 2 and 5. So we'll have to use 1 and 10, but to make it equal negative 11, we'll turn it to negative 1 and negative 10. And it'll still give us positive 10 when multiplied. So we go down here to n minus 1 in parentheses, and then n minus 10 in parentheses, and that would be your answer to this. But of course you should always check your answer, and I would check it with FOIL because that's what I prefer to use. So you have n times n, which gives you n squared. Then you have n times negative 10, which gives you negative 10n Then you have negative 1 times n, which gives you negative 1n. And then you have negative 1 and negative 10, which turns into a positive 10. So when you add it up, negative 10 and negative 1 would give you negative 11n. So you have n squared minus 11n plus 10. Oops, 10. Which is the same thing you have up here.